Hello. Now we're going to talk some more about compositions, which is where we take one function and we plug it in to the other function. So in this example, we are going to compare the order. We're going to look at h of k, and then in a little bit, we will look at similar but different composition, k of h of x. So let's jump right in. We have h of x is given as x squared plus 4. K of x equals the square root of 6 minus x. So h is what comes first, x squared plus 4. And we're going to plug into it k. So wherever there is an x in my h of x function, I'm going to plug the entire k of x function into that. So thinking about what this notation means, it means h of k of x, or rather h of x, so we've got x squared plus 4, and I'm kind of writing this in an exaggerated manner, so I'm going to be plugging something in for x. And what am I plugging in for x? I'm plugging in k of x. And what is k of x? Well, that turns out to be the square root of 6 minus x. So we have the square root of 6 minus x, quantity squared, plus 4. And if we look at simplifying this is going to give us 6 minus x plus 4. And the reason that is a square root and a square, those are inverse operations. So taking this one step further, we could simplify, and we have determined that h of k of x is equal to negative x and positive 6 and positive 4. That is negative x plus 10. So that's the answer there for my composition of those two functions. Before we move on to the other direction, k of h, let's talk about the domain. And one thing you may remember about the domain is we need to look at not just the result, but the function that went inside. And so if we look at just the result here and we think, okay, well, what is the domain of h of k? This looks like a line. So we would be inclined to say, well, that's going to be x is all real numbers, negative infinity to positive infinity. But what you need to recognize is there was a square root. All right, there was a square root in here before that square simplified it out. So if I tried to plug a number in here, I could end up with an undefined value because, of course, we know that whenever you're dealing with a square root, the radicand, whatever is under the square root, in this case 6 minus x, must be greater than or equal to 0. Simplifying that gives me that 6 is greater than or equal to x, or rather x is less than or equal to 6. So the domain of my interior function, k, is that x is in the set. Less than or equal to 6 means negative infinity to 6. At this point, we need to look at where these two domains intersect. And intersecting all real numbers with a restricted domain, that's going to give us our solution domain is just negative infinity to 6. And we can include 6, we can be equal to 6, because if I plugged 6 in, I would get 0, and the square root of 0 is 0. All right, so if we had just looked at the answer here, we would not have gotten the correct domain. We would have been inclined to say all real numbers. But when we think about what existed in the function before we applied that simplification, then we recognize that we could actually only use values of x that are 6 equal to 6 or less than. All right, let's look at the other direction. In this situation, we're going to look at finding k of h. So again, we know what h is. H is second, and h is going to be plugging in to my k function wherever there's an x. All right, so what that means is x squared plus 4 is going to go into this function for x. So let me write this out. This says k of h of x, or rather the square root of 6 minus some x. And of course, in this case, we are going to plug the h of x function in for x. So this is the square root of 6 minus, and here I have x squared plus 4. So what you want to notice is we have that minus in front of all of this. So that minus, when we look at simplifying, will distribute, and I will have the square root of 6 minus x squared minus 4, and combining like terms, we get that k of h of x is equal to the square root of negative x squared, and 6 minus 4 is positive 2. So here is my composition in the other direction, which is clearly different. So what we can see here is that the order h of k versus k of h, the order matters. All right, let's look at the domain. So when we think about the domain, we look at the result, but we also have to look at the function that went inside. And you can see here, h of x went inside. Well, h of x does not have a square root. There's no even indexed root, and there's no x in the denominator. So if there's no square root or no x in the denominator, then we will say that the domain of h, because it's a quadratic polynomial, is all real numbers. So the interior function will not affect us at all. Let's look at the domain of the result. And this part of the problem is a little more advanced than we currently are in the class. So we're going to use a little bit of logic that maybe you haven't thought of yet. And you wouldn't see something like this on your composition test, but moving forward through the semester, we will see situations that look like this. So what we know is that x squared, negative x squared plus 2, since we are under an even square root, an even indexed radical, we know that negative x squared plus 2 has to be greater than or equal to 0. Now, this is a polynomial inequality. And the way we solve a polynomial inequality is to think about graphing that polynomial. And because we're looking at greater than or equal to 0, we would say where it is above or touching the x-axis. So if I graph this polynomial, and you could just use your graphing calculator, but you're going to get a parabola which opens down and has a y-intercept at positive 2. The other thing you're going to recognize is we have two x-intercepts, and those x-intercepts are found by solving this equation equal to 0. So that would be 2 equals x squared, or rather plus or minus the square root of 2 equals x. So we have negative root 2, 0, and positive root 2, 0. So thinking about solving where this expression is greater than or equal to 0, greater than or equal to 0 is above the x-axis. So that's going to be including between negative root 2 and positive root 2. Therefore, we would say the domain of k of h is that x is in the set inclusive negative root 2 to positive root 2. This is a closed interval because we have finite bracket endpoint values. All right, so that is how we do the composition, and that's how we can find the domain with a problem like this. You may see something like this on your homework, but of course you're not going to see anything like this on the test because this is really some Unit 3 logic. So eventually it will come into play, but not right yet. Anyhow, as always, please feel free to email me, reach out if you have any questions or concerns. Good luck out there.